In this presentation, we'll discuss some key considerations with respect to mobile display components, in particular such as those found in laptops, tablets, and phones, beginning with the fact that most mobile devices use LCD technology for their displays, which immediately offers several advantages, including the fact that it's a lightweight technology, which is a primary concern for a device that you carry around with you. And LCD offers low power consumption, which again is ideal for devices that run on battery. And perhaps best of all, it's relatively inexpensive, which keeps the overall cost of your devices down. Now, I realize that statement is relative as well, but particularly for some of the younger viewers, I can assure you that this is the case. As an example, about 20 years ago, I purchased a high-quality business laptop that cost me over $3,500. The laptop I'm using right now, which I bought only 2 years ago, is also a very high-quality business model, and it cost me about $1,700. So prices have certainly come down despite the vast technological improvements that have occurred. But of course, there are always disadvantages as well. For instance, LCD relies on backlighting or edge lighting for its illumination. Since this light is always on when using the device, there really is no true representation of black, which can become challenging if your job is in graphic design or requires any kind of color matching. And if you start to lose the backlight through standard wear and tear, then the image itself may become difficult or even impossible to see, rendering it unusable, even though everything else in the unit may be functioning perfectly. Now, that said, you may be able to replace the screen or the failed light, but that can be costly and you might be without the device for an extended period, which tends to be an unacceptable situation for most mobile users. So it often results in replacing the entire device itself just for the sake of the failed light. Now, the problem with color representation can be overcome by using an organic light emitting diode or OLED display. OLED does offer more reliable reproduction of colors because OLED does not use a backlight. Each pixel emits its own light. So, for example, when needing to reproduce black, the pixel can simply turn itself off and emit no light, which is effectively what black is, the absence of light. However, OLED tends to be more expensive than LCD, which would of course drive up the cost of the device. And they tend not to be used in mobile devices such as laptops because the organic components can degrade over time, leading to decayed images still being displayed on the screen. Plus, some OLED devices tend to require more power than LCD, which of course can drain the battery more quickly. That all said, it should be mentioned that you may find OLED used in many handheld devices such as phones and tablets because most of the time those devices are off, at least in terms of the display, which helps to extend the lifespan of the organic components and of course the battery life. Another key component of a mobile display is of course the touchscreen capability, and these are certainly available on many laptops, but in today's environment, it's much more of a concern when using our phones and tablets. The underlying component of a touchscreen is known as a digitizer, which interprets the taps of our fingers into digital commands that can be accepted as input. Virtually every touchscreen these days accepts your finger as the input mechanism, but many devices also support a stylus, or a digital pen, if you will, which is far more accurate, particularly if you need to draw, sketch, or use cursive writing. Now, while this next component really doesn't play any part in how you view the display, it is worth mentioning the antenna, because if you're working on the display of a device, particularly a laptop, you're bound to encounter one or more antennas, as the screen is where the built-in antennas are placed. This is because on a laptop, the screen is the upright or vertical component, so it's the highest point of the device, if you will, and therefore the best placement option for ensuring the best quality signal. Now, there may also be multiple types of antennas for different types of communications that are supported, such as Wi-Fi, Bluetooth, or cellular. So again, the antennas certainly don't play a role in the quality of the display itself, but they are still components of the display unit. On a similar note, webcams are another component that have no direct effect on the display, but they are still often a component of the display. So again, if you're servicing the display of a device such as a laptop, you're also bound to encounter a built-in webcam. Most every laptop these days will have a webcam as a standard option, but some older models may not have one, so it will depend on the age of the unit. Now, despite the name webcam, many models also have a built-in microphone to handle the audio so that you can conduct video calls and conferences without any additional hardware. And of course, remember that if you are servicing a device with a built-in webcam, if you have to do any software reconfiguration, such as reloading the entire operating system, you will likely have to reinstall the driver for the webcam to restore its functionality as well. Lastly, like the webcam, there may also be a built-in microphone, also located in the display of your unit. Now, of course, we did just mention that if there is a built-in webcam, then it could have its own microphone also built in. But it will depend on the make and model. In some cases, the webcam and the microphone will be separate objects, or there may be both a built-in mic with the webcam and a separate microphone that is dedicated for audio use. Again, it will depend on the model. If it is built in, it should be mentioned that it might not be in the display. In fact, it could be integrated into just about any part of the case, but the screen is still the most common because it catches your voice at the most direct angle, if you will, and the built-in mics are usually more than adequate for general purpose activities such as teleconferencing, but they would not be suitable for creating content such as recording music or doing any kind of sound engineering. Dedicated devices would be required in those instances, but they would almost never be included as a built-in or standard component. So again, while several of these display components don't relate to the quality of the image you see, they are still components of the display unit of many mobile devices. So for servicing technicians in particular, they need to be taken into consideration when working on mobile devices. In this presentation, we'll examine the implementation of a Wi-Fi antenna in a laptop to provide wireless network connectivity. Now, these days, almost any laptop that you would buy would have built-in wireless capabilities, but many older models did not come with built-in antennas, so you needed some kind of adapter card or an external device that you could install to connect to the wireless network. Now, those adapter cards or external devices would have the antenna built into the unit itself, but with integrated Wi-Fi, an antenna is still required. But clearly, we don't see any metal wire sticking out of our laptops, so where is the antenna? As it turns out, for a laptop, the antenna is actually a wire that is wrapped around the outer edges of the display, which is also a part of the laptop that generally has less wear and tear, which in turn provides greater durability for the antenna because, as mentioned, the antenna is just a thin wire. Now, of course, we open and close the lid fairly often, but the body of the laptop bears the repeated force of typing on the keyboard, tapping on the touchpad, pressing the power button on and off, and it's also where people tend to rest their hands. So by placing the antenna in the screen, it's less likely to become damaged. In addition, in terms of that placement, it also helps to increase the range of reliable wireless communication and provides better performance because if you imagine the radio waves of the wireless network approaching you, they would do so just like the waves on an ocean, in that they travel on a more or less horizontal plane. So if you're standing waist deep in the ocean and you're hit by a large wave, the fact that you're standing perpendicular to the motion of the wave means that you're going to take much more of a hit, if you will, and you'll most certainly be knocked right off your feet. If, however, you start to swim, now you're in a horizontal plane as well, and the wave will affect you far less. Likewise, the screen of your laptop is in the perpendicular position relative to the radio waves and can therefore catch much more of the signal. If the antenna was in the body, it would be in the parallel position relative to the waves, and the signal strength and quality would be much lower. That said, while the built-in antenna is obviously desirable both in terms of functionality and aesthetics, it is still a small wire that is shielded by the exterior case, which can result in poor performance. So in terms of mitigating those issues, there are some things that you can try, including installing an antenna booster, which is essentially just a much larger antenna that can be added or installed in place of the existing antennas of your Wi-Fi router. Or you might consider a range extender, which is a separate device that acts as a relay and or an amplifier. If, for example, you're 100 feet from the router and you can only pick up on a weak signal, the range extender could be placed at maybe the 50-foot point. It's configured to intercept the signal, amplify it, and send it along. So once configured, now you're only 50 feet from the extender and you're receiving an amplified signal. And of course, try simply relocating either your device or the Wi-Fi router to a different location if you can. For example, in a home environment, if the Wi-Fi router is in the basement and you're on the 3rd floor, you might not ever be able to get a strong, reliable signal because you're simply too far away with too many walls and floors between you. Ideally, the Wi-Fi router should be placed as close as possible to the location of the users. Lastly, while it is rare, the built-in antenna can fail, which will typically result in losing your connectivity either intermittently or entirely. And in terms of dealing with a failed antenna, it usually isn't a component that will entirely break. The wire itself, while not particularly thick, is protected by an outer plastic sheathing, but the leads can become disconnected due to the continual wear and tear on the device itself. In that event, reconnecting and reseating the cable leads should correct the problem. But if general wear and tear was the cause of the failure, then it's likely that those leads will just become disconnected again at some point in the future, depending on the age of the device and its overall condition. But in most cases, rather than attempting to repair the built-in antenna, an external USB adapter might be a much easier solution, although it would require the user to always have that device with them to allow for wireless connectivity. But that said, depending on the age of the laptop itself, a new external adapter might also perform much better than the built-in unit if it is getting to the point where it's simply out of date. So overall, when it comes to wireless networking, antennas, and adapters, there are several options available to ensure the best possible performance, but in most cases, for newer laptops, the built-in wireless capabilities should remain quite stable, provided the unit is well maintained. In this presentation, we'll take a look at installing and working with webcams and microphones, which have become standard integrated components in most new laptops these days, but older models might not have either, nor would most desktop systems, although it's not uncommon for new desktop monitors to have them built in. But suffice to say that separate external devices are still very common. Even if your system does have integrated components, you still might opt for external due to their higher quality. These days, at least in the business world, the most common implementation would be for internet video communication or video conferencing, which of course can also be done at home or really anywhere. But in terms of the performance considerations, there are two main values of concern for the webcam. The first being the overall image quality, and this would be the same value as you would see for a digital camera or the camera in your phone, typically expressed in megapixels. And for high definition quality, you would want to see at least 2 million or 2 megapixels, which provides for 1080p resolution. The other consideration is the frame rate, which refers to how many still frames can be captured per second. The higher the frame rate, the smoother the video will be. A fairly standard value for good performance is 30 frames per second, but the higher the frame rate, the more data that must be processed. So if perhaps you're in a video conference and you're finding that communications are cutting out or the image is freezing, it could be due to a poor link over which you're trying to send too much data. So in some cases, you might want to lower these values so that less data is being sent, which could improve the overall performance. Most video conferencing applications allow you to specify these values so that they can be set appropriately for the speed of your connection. So, as mentioned, most newer model laptops and many models of desktop monitors will have a webcam integrated into the unit, which will likely be more than adequate for most users. But for any system that does not have an integrated unit, of course, an external USB webcam can be installed. These give you several advantages, including portability. In other words, the device is not tied to a specific computer. They can be used on pretty much any computer, whether it's a desktop or a laptop, Windows-based or Mac-based, or anything else that has an available USB port. And they often come with their own attachments or accessories, such as a tripod for mounting the unit or perhaps a clamp to mount the device on the top of your monitor. Also, in many cases, an external device could support higher quality than an integrated unit. Plus, they're relatively inexpensive and much easier to replace if they break or fail as compared to an integrated unit. Similarly, most laptops that have a built-in webcam will also have a built-in microphone. Now, they're usually very small in size and typically embedded somewhere within the exterior casing, but the location will vary depending on the make and model. Now, an integrated microphone does make video chatting a little more natural as compared to using an external microphone because you don't have to position the mic close to your mouth, which would of course block out some of your face in the image. But since the mic is a little farther away in that case, they also need to be a little more sensitive, which means that they can tend to pick up a lot of extra noise that might be happening in the background. In addition, most integrated microphones, while certainly adequate for most users, don't offer especially high quality. So there are certainly external alternatives that are available, including headsets, which will have the headphones and the microphone combined. And higher-end models, in fact, do produce very high-quality audio. And in fact, that's what I'm using right now to make these recordings. If you are only concerned with the microphone, however, there are many options for USB external mics in a wide range of quality options, up to and including those that would be appropriate for recording professional quality music. So it simply depends on your needs when choosing an external mic. About the only other consideration for an external microphone might be the drivers or apps required for your specific operating system, although if either of these are required at all, they would usually be included with the unit or downloadable from the vendor's website. And of course, just be sure that you have an available USB port with the appropriate architecture. For example, many newer devices might be USB-C, and if your current computer is a little bit older, it might not support USB-C, and depending on the model, it might not be USB at all. It might use a standard PC audio jack, which is usually available on most systems by default, but if you have a customized desktop, you would need to be sure that either your motherboard or your sound card has the appropriate jacks available. Most use an 1/8-inch jack, also known as a mini plug or a mini jack, but some might use a 1/4-inch jack, in which case you might need a mini plug adapter, which converts the 1/4-inch connector to an 1/8-inch. Like any external device, just be sure that your system can support it and that you have the available connections before you purchase. Other than that, most webcams, microphones, or headsets are very easy to install and use. In this video, we'll discuss some lighting technologies that are used for flat screens and other types of display devices, including both standalone monitors and those used for laptops. And we'll also talk about what's known as an inverter, but we'll come back to that shortly. So first off is the cold cathode fluorescent light, or CCFL. This is a lighting technology commonly used in LCD monitors, some neon signs, and even some internal computer case lighting, which is quite common in custom gaming systems. But this type of lighting is used primarily with LCD monitors because they do not produce their own light within the liquid crystal display material. they need an additional backlighting source, which is the job of the CCFL. It's basically just a standard fluorescent light, the same as you might see in the ceiling of an office building, just a greatly scaled down version. Now, while you obviously require the CCFL for any LCD screen, it is an extra component. In addition, it also requires the inverter to power it. So again, we'll talk about the inverter shortly. But basically, with the inclusion of the inverter, it typically means that LCD screens tend to weigh a bit more, and they also tend to draw more power. As for the light itself, as mentioned earlier, it's essentially just a greatly scaled down version of fluorescent lighting, typically implemented as a small tube, which is able to provide adequate lighting while not raising the ambient temperature too much, which helps to prevent overheating and subsequent damage to other components. Now, depending on the size of the screen, smaller units could usually get by with just a single CCFL in conjunction with a diffuser to help spread the light out more evenly. And the CCFL itself is typically located in either the bottom or the top of the screen itself, possibly both in larger screens, with some of the largest models possibly having more than two. Maybe there would be one located on either side as well. But bearing that in mind, and I mentioned that I'd come back to this, for every CCFL you had, you needed another inverter. The inverter is simply the component that provides power to the CCFL. It's called an inverter because it can convert the DC power of something like a laptop battery to AC power, which is what the CCFL itself requires. So if you had more than one CCFL and the associated inverters, of course, the overall weight is going to increase, as will the ambient temperature. Now, of course, manufacturers would be entirely aware of this, and they would be sure to stay within safe operating limits, but it's something to consider if you're trying to assess damage to a unit that requires servicing. But for many newer model screens, LED has become the standard, superseding the CCFL as the primary lighting technology. LED stands for light-emitting diode, and it's implemented as a semiconductor device that emits visible light when an electric current is passed through it. And as mentioned, they have now become the standard lighting technology for most monitors and laptop screens. LED is also the core technology behind fiber optic data transmission and many types of indicator lights, so you'll almost certainly hear the term used in many applications. But for monitors and laptop screens, LED provides several benefits, beginning with a much lower power requirement because LED lighting does not need an inverter, which by default also decreases the weight. They're very efficient, which translates into producing very little heat. Due to that fact, they also have a very long lifespan, and they produce good quality light, so it's easy to see why LED has superseded CCFL as the core lighting technology. Like any component of a computer or a laptop, though, it really is just a matter of knowing what you have in terms of servicing existing units and or knowing what you want when buying new. But these days, I doubt you'd be able to find many new models that still use CCFL technology, but they might certainly still be present if you're acquiring used equipment. In this presentation, we'll take a look at the role of a digitizer with respect to a touchscreen. Now, a digitizer itself is really any type of device that can produce a digital output from a non-digital or analog input. Now, a quick side note here, the term analog can apply to many things, and this is because it can really refer to anything that isn't digital. But the term itself is drawn from the word analogous, meaning that the input you're dealing with produces some kind of signal that is similar or analogous to the original. As an example, when you speak, you produce sound waves. But if you want to record your voice, you would speak into a microphone. Inside the microphone, there is a very thin metal diaphragm that vibrates in response to the sound waves you produce. And those vibrations are then passed into the recording device as variations in electrical current. And it's those electrical currents that are similar or analogous to the original sound waves themselves. So that's an example of using an analog recording. However, those analog signals can also be converted into digital information for more reliable storage and reproduction. Using the voice recording as an example, if you've ever tried to make a copy of a copy of a copy with that analog information, each iteration almost always degrades until eventually the information just isn't usable anymore. But with digital information, it's all just a series of ones and zeros, which can be identically copied in theory an infinite number of times with no degradation at all. So any kind of digitizer simply performs the process of digitization or converting analog information to ones and zeros. So back to the topic at hand, for a touchscreen, the digitizer accepts the analog information of where something like a stylus pen, or in most cases just your finger, is placed on the screen. The precise location is interpreted using standard X and Y coordinates, then those coordinates are passed to the digitizer to be converted into digital information, which can then be used by the processor to produce the desired output. These days, touchscreens are, of course, ubiquitous. Almost everyone has either a phone or a tablet or both, which are almost entirely controlled by a stylus or your finger, and it's essentially because of the digitizer that users can perform such operations as writing or drawing directly on their screens, or placing a cursor within a paragraph, select and highlight, copy and paste, or, of course, load an app. There are any number of operations that can be produced as output, but all of them are dependent on the digitizer to provide the appropriate input. That all said, touchscreens are certainly not unique to phones and tablets. Many standalone monitors are equipped with touchscreen interfaces, as are many models of laptop screens, and they're almost always used where mice and keyboards just aren't appropriate or available, or where they would simply be less convenient, such as information kiosks or point-of-sale systems. In terms of format, so to speak, there are typically two implementations: built-in, which would be something like your smartphone or your tablet, or a standalone or dedicated task system such as a kiosk or a point-of-sale. There really isn't much of a difference in the technology itself, and both implementations would still require a digitizer, but the touchscreen of a dedicated device, such as a banking ATM or a kiosk, would have far fewer output options since the device itself is only designed for a very limited range of operations. In both cases, though, when it comes to servicing, you could likely replace just the screen itself in the event of damage or a malfunctioning unit. All in all, touchscreens most certainly offer a lot of convenience, but of course they do require some simple maintenance, such as regular cleaning, and particularly in the case of mobile devices, they're quite easy to damage if dropped or stepped on, so it's recommended to use a protective case as well to reduce the likelihood of damage. So in this course, we've examined how to recognize and how to install and configure various hardware and display components. We did this by exploring replacing hardware and devices including hard disk drives and solid-state drives, migrating from hard disk drive to solid-state drives, wireless card types, Wi-Fi antenna connectors, webcams and microphones, physical privacy and security components, LCD and OLED, mobile display components and laptop screen inverters, and digitizers and touchscreens. In our next course, we'll move on to explore how to set up and configure mobile device accessories and network connectivity.